Actually, let's see. Find all tangents. Find all tangent lines to f of x equals x over x squared plus 2 that are perpendicular to the line y equals 16x. Then draw a graph to illustrate that you are correct. Now, as for the graph, you can use a calculator. I'm not expecting you to know how to graph this function at the top of your head, so you can use a calculator. Or I should say graphing calculator. Scientific calculator is always allowed on the exam. And I'll say for this particular thing, you can use a graphing calculator. You know, or Desmos or Wolfram or something like that. Now, it's okay for right now, if you want to work out this problem, it's okay for right now. If you just want to do the first part, just find the two tangent lines. And then I have the graph already prepared. You can wait on the graph if you don't want to kind of figure that out. The graph is kind of just like a fun afterthought. I don't think I would put that in an exam anyway. But it was kind of just to make the problem a little bit more fun. Okay. How do you think? How much time do you think I should give? Jacqueline, how much time do you think?
Like 4 minutes, I guess, or 3. I don't know.
All right, four is good. Might need a little more. That's okay. Okay, so let's discuss this. It's okay if you didn't quite finish. Our desired tangent line have slope -1/16. So we must first solve the equation f prime of x equals -1/16. Are there any questions about that? Kind of just the outline of what we're doing. Because now we're going to do all the little steps in between. So let's first get the derivative. So like Caleb said, we're going to use quotient rule. So let's see. So f of x at the top of the screen, x over x squared plus 2. So let's see. So f prime, so 1 f prime g minus f g prime all over g squared. Okay. So if you simplify the top, it's pretty easy to simplify. So we just get negative x squared plus 2 all over x squared plus 2 squared. That's our derivative. Okay, good. Now we're going to set this equal to -1/16. Okay, so negative x squared plus 2 over x squared plus 2 squared equals -1/16. Okay, so I'm going to cross multiply here. So I got -16. I'll actually just write it out explicitly. -16 times negative x squared plus 2 equals x squared plus 2 squared. Okay, now let's multiply everything out, right? So we get 16x squared minus 32 equals x to the 4 plus 4x squared plus 4. And then we move everything over, say, to one side. We get x to the 4 minus 12x squared plus 36 equals 0. And that we can factor, right? We can factor that as x squared minus 6 squared. So we get x squared minus 6 equals 0. X squared equals 6, and we finally get the two solutions that we're after. X equals plus or minus square root 6. Okay, so that's all the algebra there. Yes, Caleb.
So
Did you realize your mistake
right
now?
there? Yeah,
Right here.
So I didn't set them like, no, up top, like where it says negative x squared plus 2 over, yeah, that thing. I changed it to just -1 over x squared plus 2. Like I canceled them out. Can I do that?
I'm not exactly sure what you're saying. You said you did not use this expression on the left-hand side?
No, I got that, but then I like simplified that to just -1 over x squared plus 2.
Well,
And then
you have to be careful
the
here.
denominator to equal 16.
You have to be careful. That negative is not multiplying the whole thing. So you would be right if it were negative x squared plus 2 like that. And then you can cancel out one of the x squared plus 2's. Right? Then you can cancel this out and say that's -1 over x squared plus 2. That'd be correct. But notice the negative is only on the x squared, right? So there is no common factor here to cancel out. Okay, good. All right, so it's always good, even if we make a mistake, we find out, where the mistake was made. So that's kind of a little algebra mistake, but then I think if that was correct, I think that would have been the correct answer, 14. Okay, now let's just make sure that we actually do answer the question. The question said, find all tangent lines. So right now I just have the x values of the points of tangency. Now I need to actually find those tangent lines. So first of all, I'm going to rewrite the original function because we do need that, right, to get the points that the tangent lines pass through. Okay. So here's tangent number 1, and we'll do tangent number 2 on the other side. Okay. Okay, so the point here was, so negative root 6. If I plug in negative root 6 into my function, what do we get? We get negative root 6 over 8. So that's my point. And if I do the point for the other tangent, I have positive root 6 for the x value. But now the y value is positive root 6 over 8. My slope is obviously the same in both cases. My slope is negative 1 over 16. But that was the whole point of this. And then I could say, what is my equation? My equation, actually I don't need this. Let's move that down a little bit. Okay, so the equation of my tangent line here is y equals negative root 6 over 8 minus 1 over 16 times x plus root 6 over 8. And then the equation over here is y equals positive root 6 over 8 minus 1 over 16 x minus root 6 over 8, right? So those are my two answers. Those are my two tangent lines.
Wait, why is it x plus root 6 over 8? Not
Remember,
x
point slope
plus
4, it's x.
root 6.
Sorry, it should be root 6. I didn't mean to put the
Okay.
8s. Thank you. So just correct that. Miriam just corrected me. I had the wrong, whoops. I initially wrote the wrong numbers here, right? They should be root 6, not the root 6 over 8s. Okay, so this is the graph. I've already prepared it. So we can see the graph of the function we were given, right? Y equals x over x squared plus 2. That's the blue curve. Now, keep in mind that the line that we're given is this line, y equals 16x. And so the two tangent lines that we were looking for are, in fact, these two tangent lines that are also marked, the orange line and the pink line, right? Occurring at the point of tangencies are negative root 6 and positive root 6. And so you can see that they actually are perpendicular to the green line. They really are perpendicular. How I've drawn it, I kind of drew the graph in Wolfram and then traced over it so you can see a bit more clearly. It may not appear quite perpendicular, but they are. Now, the interesting thing about this is, I didn't realize this until I graphed it. So when I graphed it, I noticed that the tangent line, for both cases, notice that the orange tangent line actually is, if I look near the function, it's both above the curve and then it actually then goes below the curve, right? So the point of tangency at x equals root 6, half the line is above on the left and the other half is below the curve on the right. Does anyone know why that actually occurs, right? Because usually this is not a normal occurrence. Normally, when I have a tangent line, it kind of just is below the curve. I mean, it eventually might intersect somewhere else, but near that point, it's just kind of below or above the curve. Does anyone know why at the point of tangency in this case, we get that split right at that point? Does anyone know why? So it's actually because what's happening here is, now you can't see it because the graph, we're zoomed out too much. What's really happening here with the original graph, let's exaggerate this. So this is kind of an exaggerated form of x over x squared plus 2. And then the points of tangency are kind of occurring right here. So these actually turn out to be what are called inflection points. So inflection points are points where the curvature of the graph actually changes. So in this case, the graph is curving downward, and then it switches to curving upward. Here it's curving downward, and then it switches to curving upward. And so it turns out that at inflection points, the tangent line always straddles the curve. So if I were to draw the tangent line here, one half is above, and the other half is below. And so I didn't notice that until I actually graphed this. And then you can actually work out, if you get the second derivative of this function and then set it equal to 0, you actually do get root 6 and negative root 6. So it's interesting that this particular function, I just kind of coincidentally chose the numbers so that it works out to be the inflection points, which is kind of funny. But inflection points we won't do until